Okay, welcome to the 6P for week 2, Introduction to Digital Audio. This is Sound Design. All right, so let's start right in. We don't have much time to do this, and I need to cover quite a lot. So let's take a look at what is digital audio and analog audio. So as we know, reality is a continuous form, okay? That means that it happens on an ongoing basis all the time, all right? And what we have is analog is a recording of the continuous. It measures time, distance, and pressure. All right, these are all continuous qualities, and it can measure them in an infinite number of values, and these values are infinitely divisible. Analog recordings remain continuous. It records everything. There's nothing that's lost. Okay, so it's a continuous thing. When we're looking, and let me show you this. These are some examples of the different kinds of audio interfaces for analog. We've got the record player, vinyl, which uses grooves. Okay, we've got two different types of tape. One, the center one is called a reel-to-reel, and the other one is called a cassette tape. Essentially, they work the same way. They record electromagnetic signals onto this tape, okay, which is a magnetic tape. All right. Digital audio. Digital audio is different, though. Digital audio is a sampling. It's discrete. It doesn't record continuously. Rather, it takes snapshots of things. All right. This means that time, distance, and pressure are not recorded continuously, but are approximated in a digital format. Okay. We sample the signal. We sample the sound. It's kind of like taking photographs. In terms of sound, when we digitize sound, it takes a snapshot, a certain number of snapshots per second. Right? And those snapshots put together create what our ears perceive to be continuous sound. Right? Very much in the same way as a series of photographs, when presented at a certain rate, our eyes perceive as a continuous motion. Right? So this is the same thing. And if we look at the bottom here, what we have are two graphs that kind of show, three pictures that kind of show what digital looks like in analog. Analog is the nice smooth curves. And digital is either blocky or spiky kind of a thing. And this is because it's taking snapshots. Okay? It's recording instances rather than continuous. Right? Next we have the bit depth. So if the sampling rate in sound is like a number of frames in a video, okay, then bit depth is the resolution. It measures, I guess you could say it's the equivalent of the megapixels, or the resolution that's used. All right, so we measure sound depth in bits, and this kind of gives us a dynamic range. All right, how loud, how soft, and how deep the sound is really. Okay, so let's take a look at a couple of examples here. So what we have here is a digitized stereo waveform. All right, and this is what it looks like in most DAWs. And what we would have here, okay, is, I guess, a very specific magnified look. And each of those points is the distance between the snapshot, or there's a snapshot, and the space between it is the distance between snapshots. The distance between it kind of, and the space between it is, we also have as depth and resolution. All right? So when we look at something like this, we have to be aware, okay, that it really is the equivalent of a snapshots. Okay. Digital audio, as it says here, is closely spaced snapshots of analog audio. It's an incomplete picture. All right. Because it's snapshots, there are spaces, and so what do we do with those spaces? Well, those spaces, we have to provide something. So we provide some white noise, right? And the white noise is added during input of the recording. And we call it dithering, very much in the way your graphics are dithered, okay? So if you ever zoomed into a text very, very closely, you'll see it become pixelated, and there's a fading from, let's say, black to gray to white, and that's called dithering. Well, we do very much the same thing with audio, okay? And when we digitize, we have to fill in the blanks, all right? So let's take a look at some samples of what digital audio are. These are some examples. On the bottom side there, we've got what's called an H4n handy recorder, okay, and it stores that on an SD card. In the center there, we've got some CDs. I'm pretty sure you're familiar with those. And then the other way we can store things now is through on portable devices such as a USB thumb drive or even a hard drive. Okay, so these are all digital formats. All right, now let's take a closer look at things. Just because we have analog and digital doesn't mean that they can't work together. In fact, they have to work together in this day and age. And so we have to be able to convert analog to digital and from digital back to analog. This is a requirement, all right? So, for example, as I'm presenting to you, I'm analog, and I'm recording it into digital format. So something has to happen here. So what happens? Well, let's take a look. We've got a microphone, which has some elements in it. One of them is a transducer. And this takes that audio signal, and it turns it into electromagnetic pulses. And these electrical pulses travel through the cable into what's called an ADC sound card, or analog to digital converter. Okay? This is usually a sound card in your computer. And that will convert the audio signal, the analog signal, into a digital format. And it sends that to your computer through a wire, usually. All right? So it takes an analog waveform, and it sends it into a digital waveform. We do all our work on our computer with it, and we want to push it back out. Now, we have to convert it to an analog audio form. So we send it back out to a DAC, a digital to analog converter. And this, again, is usually a built-in sound card. All right? So the sound cards in your computer have ADCs, DACs built in. All right? So it sends it back out to the speakers. All right? And that's how it comes. So if we look at the bottom graphic there, the top part of that graphic at the bottom shows a regular wave that comes into an ADC, all right, and is being pushed out into bits and bytes, okay, binary code. Computer can read that, translate that into sound. When it sends it back out, it's sending out that same binary code, and we have the digital to analog converter. So that converts that sound, the code, into analog sound. All right, let's take a look at some things. Recording to analog. So before we had computers, we used to have to record straight to tape, magnetic tapes, and there's different size tapes, and different size tapes would give you different resolutions. As you can well imagine, you'd get a higher quality the more space you had to fit more stuff in, right? So the number of tracks you could record was limited by the heads, the number of synchronized recorders, and the thickness of the tape. So some tapes we could get very thick, and we could have 4 to 8 tracks on there. In fact, there was something called an 8-track tape. Number of channels on a mixing board would be funneled later to whatever tracks were desired on the tape. So you could have as many inputs as we wanted. These would then be funneled back out to certain tracks on the magnetic tape. All right? So mixing and mastering were very, very important at this point because you had to get it right. Okay? So this is what a mixing console looked like. You can see it there. All right? And let's move on. now we've got Pro Tools and other digital audio workstations, or DAWs and DAWs. All right. So we've got Pro Tools is the one that we're going to be using primarily. All right. And stereo recordings, we normally have 2 tracks, right? Left and right. Mono is a single track. And this is the typical. It's not to say that we can't have more, but this is fairly typical. So stereo recordings are usually can be achieved using built-in microphones, even your mobile phone audio recording. It's capable of doing that. All right. Audio tracks on movie files are also often in stereo format because they've been produced in stereo format and then pushed out. So the stereo files you are familiar with are usually a consolidation, right, of sound recordings into a single track, or they can then split it up into the stereo. Okay. Music and audio tracks attached to videos are usually consolidated sound sources, right? And they can be from multiple sources, but a lot of times these are mono, and they bring them into one track, and you get another one bringing into another track, right? And then they're remixed into stereo or surround sound. But you can record directly into stereo, record directly into surround sound. Okay, so let's take a look at some of the things here. All right, the major DAWs that are out there, these are the ones that are recognized by industry, and professionals use them. All right, so we've got Cubase, Steinberg Cubase, all right, and Ableton Live. They're still fairly well known, as is Propellerhead's Reason, right? But these are on the other side, the more individual side. Most professionals are familiar with Pro Tools, Logic Pro, and Studio One and Motu. Okay. Again, these are all very, very well known. GarageBand is a small amateur DAW. It's good for amateur work. To this list that you see here, I'd like to add one more for amateurs, which is Audacity, because it's a free download. It's simple, easy to use, all right? And it's used quite often in small studios, all right? Small recording studios quite often use Audacity because it is free. All right, let's move on to the next thing here. What makes up a modern recording studio? Well, we've got several things here. Interfaces of various types, instruments of various types, all right? So input devices, microphones. Microphones are very, very important, all right? Music instruments, electric guitars, electric or acoustic drum kits, keyboards, all right? MIDI keyboards and MIDI controllers, all right? So this is one part of it. The other one is we've got a DAW, right? So as you can see, we've got Ableton or Cubase or Pro Tools, one of these that you see on the screen there. These are essential. This serves as the brain, okay? And it can control the recording and the playback, all right? We can sequence and arrange the tracks. We can mix the sound levels, and we can apply special effects, which is sometimes necessary. And then, of course, there's the mastering of this, all right? So this is all part of that process, all right? The modern recording studio also has interfaces. Now, we have to have an audio interface and a MIDI interface, all right? Now, usually both of these are through USB ports nowadays, even the MIDI one. But there are MIDI interfaces, direct MIDI interfaces that we still have. Okay, outboard and routing gear. So audio mixers and effects processors, these are usually often optional things because a lot of times the DAWs have certain plugins already. But it's always good to have these extra effects processors, right? They connect the computer with other devices, and they can help support the audio production process, especially if you don't have a very powerful computer. So having these external things takes away some of that processing power and helps your computer run. Output devices. speakers or headphones. Now, if you've got a studio rig, you want both of these things. You want both a headphone as well as different, distinct, good monitoring speakers. All right, it makes a difference. All right. So let's take a look. You should be familiar with this next place. It's here, the Synth Lab. And so what we have is we have an audio and MIDI interface, which is on the left side. We've got the synthesizer, which in this case is a mini Moog. We've got Pro Tools running on the computers. We've got an audio mixer and a MIDI keyboard. Now, at the moment, we don't really use the audio MIDI interface as much anymore because it's not necessary. The software has advanced to the point where we can skip that audio interface and go directly in. In fact, our mixer is the only audio interface that we need. Okay? All right. Next thing, let's take a look at the typical connections. All right? So the connections happen in a variety of ways depending on what equipment you have. But essentially, you've got your microphone or your input device, which will go into your, let's say, audio interface. All right? And then these will go out to the computer, okay, as well as to the speakers. You also have coming into your audio interface a variety of other devices, such as keyboards or MIDI devices, MIDI boxes, or controllers. All right? So all of this goes in and then out. That's one possible setup. And to try and explain everything, if we're going from the audio interface out to the speakers, out to the computer, from the computer back into this thing, down to, you can take a look at the diagram. The arrows pointed out to you directly. So I'm not going to waste too much time with that. Let's take a look at the other side. Again, we've got a mixer, we've got computers, we've got monitor speakers, we've got audio interfaces, we've got instruments and input devices. Again, these all get wired in and get routed through different systems. Ultimately, any external device gets routed to an audio interface. The audio interface sends the signal out to the computer as well as to the monitor speakers or to wherever else it needs to go. Right? And the processing happens there. In many instances, your computer is now capable of processing things, so you don't need to have the audio interface, or it's not as necessary unless you've got a weak processor. All right, let's take a look at the mobile rigs. A mobile rig is really meant to be portable. It's meant for you to be able to go out into the field, to record out in the field, or to have to move around from one location to another. This can be either outdoors, or it can be from one studio to another studio to another studio, or small studio setups, somebody's house, a small room. These are portable setups. So what do you need for a portable setup? Well, ideally you'd want to have some sort of MIDI interface, say a MIDI keyboard, so if somebody wants to play music, they can, right? You would need to have a field recorder. Again, this enables you to record. Now, the nice thing about the one that we have here, the H4n Zoom, is it can record. It's got built-in microphones, but it also has two inputs for external mics. So you can actually use external microphones and record directly into this. Okay? You want monitoring headphones because you need to be able to monitor the sound levels, especially as you're recording. And then your MacBook or any other computer, actually, laptop, that's capable of running a DAW. And that's really essential. Your computer, it cannot be just any laptop. It does have to be a laptop capable of running a DAW. And then you'll use those headphones to do your post-processing along with Pro Tools or Logic Pro or whatever DAW you happen to be using. All right. The next one is the fixed studio setup. Now, the nice thing about having a fixed studio setup is that you can have a lot more equipment there because you don't have to bring it around. Of course, that means you're fixed. You can't move. You can't go out and do outside projects. They have to come to you. That could be a problem, right? So A fixed studio, though, you normally have a mixing desk. It's got usually a larger mixer of some kind. Can be anywhere from 8 channels to 64 or 108, 28 channels. It really depends on the studio. All right. You will have a full-sized MIDI keyboard. This is usually one that's not just a small kind of dinky thing. It's a full size so you can play out with it. There's a lot of other alternate settings there. You'll also have at least a good set of monitor speakers as well as headphones. You want to have both of these things because when you're mixing, you may need to mix for both things. The fine-tuning will be really in your head, okay, on this. You also may not want to have the speakers going as you're mixing or mastering or as you're recording something because of feedback. All right? This all depends on your studio setup. Now you want to have a desktop computer. No point having a laptop computer for a fixed studio. Get as much power as you can. Get a top-of-the-line computer. You want to be able to run a DAW. Again, the two most common DAWs to use on a professional level are Pro Tools and Logic Pro. All right, let's take a look at some of the cables that are used here. Cables are really, really important, okay? We have to have several different types of cables. Some of them help to power everything up. Other ones, help to transmit the signals to different parts, okay? So let's take a look. We've got power cables, and power cables are essentially what gives all our devices the electricity it needs. Please do not overload things. You've got a certain, you should know what your power load is before you just start plugging things in when you set something up. Now, for portable rig, chances are you're not going to overload anything because you don't have that much to plug in. But for a fixed studio, make sure you know what your power load is and then plug in carefully. All right. Next up. Next up are the audio cables. All right. And audio cables, they come in different forms, and they basically carry an electrical signal. Okay. So, as it says here, audio cables carry audio information in the form of electrical voltage. And in some ways, that's the simplest explanation. For analog, we use XLR cables, so microphone cable. This is that 3-pin one. You'll see the picture down there. There's RCA 1/4-inch cable. All right. And this is the one that has got the red and white little plugs in the sleeve that goes around it and plugs into things. Okay. Often, it also comes with an 1/8 inch on one side and the RCAs on the other. All right. 3.5 mm cable, usually used for speakers, also known as 1/8 inch. These are small speakers cables. Larger speaker cables may use 1/4 inch. All right. We can use them for headphones. 1/4 inch is also used for electric guitars, synthesizers, and things like that. Okay. If you've got a 1/4 inch, you might need to get a converter for 1/8 inch, and if you've 1/8 inch, you also may need a converter for 1/4 inch. Up to you. Suggestions there. All right. Digital cables. These are optical cables, coaxial cables, such as what you would find for fiber, for long distance things you would use coaxial cable. Composite video uses coaxial cable. These are digital signals. All right. And then of course we've got MIDI cables, USB, and FireWire. Again, I would actually throw these along with the digital side simply because they're used to carry signals in a digital format. All right. So let's take a look here. MIDI cables. This is an old cable type, and in fact, most times now MIDI devices are USB. All right. However, there are still some old MIDI cables and MIDI devices out there, so you should have the capability to plug those in. And nowadays, you can actually get these converters that you can plug in. All right. USB and FireWire. These are most commonly used by computers. However, there's a couple of new wires that have come out that are also being used. One is HDMI, the other one is Thunderbolt. These are both high-speed transfer, although HDMI is used mainly for carrying both video and audio, and Thunderbolt is a data. Right? So that's pretty much it in terms of all the different types of cables and studio setups. It is important that you know what kind of cables to use, what's analog, what's digital, all right, and how to identify what goes where. This will help you in the flow of things, all right? So really, ideally today, you should have learned to be able to explain the various components for a digital audio workstation. In other words, a workstation that you have here. You should be able to differentiate between input and output devices, right? Which ones are input, which ones are output? Microphone, input. Speakers are output. All right, good. You should be able to know which ones are hardware, which ones are software counterparts, and sometimes there are both. You can have hardware mixers and software mixers, but which one is going to be better, for example? These things you need to know, right? Setting up a DAW to support audio recordings, editing, music arrangements, mixing, and mastering, all right? This will come slowly, but we've taken the first steps for this one. And lastly, you should be able to start using the terminology that has been presented and that you've discovered. For example, many of you should have discovered that quarter-inch cables often come in two formats, okay? One is called a TS and one is called TRS. You should be familiar with these two terms. You should know what they mean, okay? Tip sleeve and tip ring sleeves, all right? You should know that one is unbalanced and one is balanced. The TRS is a balanced one. And you should understand what that means, okay? So that's pretty much it for today's 6P. Last thing here is please do some homework on your own. Here's a guide to starting your own studio. You can follow the link there, and good luck with it. You should be able to start up a very basic studio on your own, okay? So thank you very much, and I'll see you next week.